In this video I'm going to show you how to deal with some of the kinds of annoying spreadsheet data that you can come across when you're wanting to do some statistical analysis. If you end up doing any kind of real world work as an econometrician, quantitative analyst, whatever you want to call it, you will definitely have to deal with messy, evil little data spreadsheets that don't come in a form that you want them to be in, and you need to be able to handle that. So here's just a little example of a spreadsheet with some data like that. So it's already a CSV file, and we have a cross-section of some data on some individuals, and the variables that we have for those individuals are their name, a variable called appeared, a variable called gender, a variable called evil, and a variable called random. Okay, and we have a total of, 17 individuals here, and data for all of those. Now, the first thing that's different about this spreadsheet, this data set, compared to others that we've seen, is that we have some of these variables that have text in them. They're not just purely numerical variables, and that's fine. So you can read these kinds of data sets into R and deal with them, and sometimes that's very, very helpful. Doing statistical analysis on people's names is not something that we'll deal with, but doing textual analysis is certainly something that you can do within R. But take a look at this gender variable. So you know, you've seen before how to deal with dummy variables defined in terms of whether individuals are males or females. And in this case we have a spreadsheet which has M's and F's, okay? So it has letters and not numbers. Now, one thing that you could do is you could just go through yourself, and every time you see an M you could type a 1, and every time you see an F you could type a 0. You could work your way down the column, and because there's only 17 observations that won't take you too long at all. But the trouble is that the data sets that we typically deal with in practice are not 17 observations. They might be 400 observations or 4,000 observations, and you're just not going to sit there and do that. So we need something better, a better approach to deal with that kind of thing. And I'll show you today how R deals with that very, very easily, actually. Another thing to notice about this spreadsheet, apart from the presence of text, is that we have some missing values, which is not something that we've seen so far either. So this appeared variable, for example, has numbers for most of the individuals, but for one of them it has this NA thing sitting here. So NA is the kind of official R code for not available, a missing value. Okay, so as we'll see, if we read this into R, it will recognise this as just being a missing observation, and that's fine. We will also see, when we read this into R, and we'll check this, that this NA here will be recognised as a missing value as well. Okay, so we have this one mysterious individual here who does not have a name, even though we have some other data. We know that this individual is male, and we know that this individual is clearly very, very evil, but we don't have his name. And finally, this variable at the end called random, and it has some numbers and it has a bunch of missing values as well. And this is something that happens all the time in kind of real data analysis as well, is that the missing values of them are not of the form NA, okay, that R recognises as a missing value. Instead, there's something else. So sometimes you'll get these spreadsheets and they look exactly like this. They have a decimal point in them. So you're going to see one of these in a tutorial exercise. Sometimes you just have a completely empty space. We're going to see that R will not recognise these as missing values, and we'll do something funny, and I'll show you how to deal with that as well when we read this into R. Okay, so there's just a few messy kind of things here. There's no new econometrics in any of this, just some messy data issues, but what you find when you're doing this kind of stuff is that you can spend just as long kind of cleaning up your data set as you do on your actual analysis. Alright, let's get this data into R then. So we'll go across here, and here is our evil.csv file, and I'm going to make sure that I set my working directory. Alright, let's start with a new piece of work here. An R script. And let's read in the data. So we'll just read into some data frame data that says read.csv evil.csv. Okay. And I'll save this as evil.r and we'll run that. And let's have a look at the environment that we've created here just to check that this has come in. So what you can see is that this data frame looks in most respects like the CSV file I was just showing you before. We have the names of all of these individuals. Notice these NAs here are being denoted in this faded out kind of format. So R is recognizing those as being observations that are not available. Okay, there's no name for this individual, there's no gender for this one, there's no appeared for this one. On the other hand, these are not being registered as NAs, and we're going to have to deal with that at some point. So first of all, before we talk about those, let's return to this gender variable, these M's and these F's, and see how they work. We'll see what we can do with those. Okay? Let's suppose we want to do a regression to see if, on average, males are more evil than females, okay, or vice versa. So we'll just do a little regression that says we're going to print a summary of a regression of evil on gender from this data frame. Okay. Now, when you look at that, you would think that's a silly thing to do. There's no numbers here. How can I do a regression on M's and F's? Now, what R is going to do is it's going to handle this, and I'll show you how. So let's just run that and have a look at the results. You can see it's done a regression here. There's the results. What R has done is it treats this gender variable as being a factor. Okay, if I just show you this gender variable here, it recognises that there are two values. So when I print out gender here, it gives us the M's and the F's that you've seen in the data set, and it calls this a factor, and the levels of this factor are F and M. So it's recognising that there are two possible levels. It ignores the NA, it knows that that's missing. That's not a third level. When it does this regression, it actually does for you. It constructs the dummy variable for you and does the dummy variable regression. And this is the result here. Okay, so it's done a dummy variable on an intercept and gender being equal to M. Okay, and so the average amount of evil when gender is equal to F for a female is 0.6. The average amount of evil for a male is 182 plus 0.6, so 182.6. So that's apparently a big difference, but the difference is not statistically significant. There you go. So R will automatically, if you read in this kind of text variable, R will treat that as being a factor and create dummy variables for that factor. So equivalently, what you could do, if you want to check that it's really done kind of the right thing here, is you could create a dummy variable yourself just to check this. So if we go dt, let's say male, whoops, not that kind of male, is dt gender is equal to, what is it, M. Okay, so that's a logical statement. So what I've written there is it's going to look at this gender factor, and the double equal signs mean we're doing a comparison, right? So we're comparing the gender variable to the letter M, and every time it sees the gender is equal to M, it'll say true. Every time the gender is not equal to M, it's going to say false. And then to turn that into a dummy variable, I'll just multiply that by 1. Okay, so what that will create is a numerical variable, male, which is equal to 1 when gender is male, It's going to be equal to 0 when gender is F female. Okay, and just to prove that to you, let's run that and check out our data frame again. And here it is, right? So males are 1 and females are 0. So these are the dummy variables that you're used to dealing with. Okay, and if we were to do a regression like this and replace gender with male, then we will get the same answer as we did before, just with the male dummy variable. That's what you're used to seeing, right? So you can, in R, you can just directly put these M's and F's into the regression, and it will work it out for you. All right, so far so good. Now what we would like to do is to do a regression of evil not only on male, but on the, we want to regress evil on male and the log of the random variable. So that's going to look like this. We're going to go log male, and we could use gender, it doesn't matter, either will be fine, and random, like that. Okay, and now we have a problem. So down here we've got an error message. Error in math factor random. Log is not meaningful for factors. So you look at that and think, what on earth does that mean? Let's go look at our data frame again. This is the problem that's arising in this random variable here from these missing values that have been coded as decimal points. And other times they might be coded as spaces or blanks or whatever, but they're not coded as NAs, they're coded as something else. So what R has done here is it said, well, these decimal points, they must be like M's and F's and names and these things. They must be characters that you want to read in. And so what it's done is it's read in this random variable here and said, well, it's treated it as a factor. Okay, some of which are equal to this decimal point, and others of which are equal to these numbers. But R is not recognising them as numbers anymore. It's recognising them as factors, as if they were M's and F's and names and everything else. Okay, so this is no longer a numerical variable, even though it looks to us like a numerical variable. R is not treating it as a numerical variable because the NAs have been coded as these decimal points, as something different. So we need to do something about that. Now there's a few different things that you could do. Again, you could go back into your spreadsheet and you could deal with them yourself, replace these with NAs, and then that would be fine. And if you've got 17 observations, you'd have that sorted in a minute. If you had hundreds or thousands of observations, you'd be there all day. If you did it manually, or you could do something cleverer in Excel. But I'm going to show you how to deal with it in R. And again, there's different ways in which you could approach it. Now, one thing that you could do, here's a kind of a, just to show you the beginnings of what we might do. Notice that the second value of random is equal to this decimal point thing here. Okay, so down at the console, just to show you what you could do, let's put the second value of that random to be an NA. So I'll get that out of the way. Okay. So if we refresh that data frame, you can see that I've changed that what was this dot into an NA. Okay, so you can, observation by observation, change the data into NAs like that. Now, obviously, you're not going to do that one by one. What you can do is the following, and I'll put it into our script here. Okay, ultimately, this line here is the regression that we want to run. We can't run it yet. We've got some work to do first. So I'll just comment that out so that it won't run for the time being. What we can do is the following. We can go dt random, and instead of just referring to observation number 2, what I want to refer to is all of those observations which are equal to that annoying dot thing. So we use, kind of like this, we use a logical statement. So I'm going to put in here dt random equals dot. So what that's going to do is for every element of this random variable, it's going to compare it to a dot. And if it's a dot, it's going to say true. And if it's not a dot, it's going to say false. And so for all of those observations which are dots, I want to replace them with NAs. Okay, so let's run that thing now and go and look at our data set, and that's done the job. So all of those are now being treated properly as being NAs. So that's a step in the right direction. R now knows that those dots are not data, they're not characters to be analysed, but instead they're missing observations. However, you can still tell, if you look closely, by looking at this data frame printout, that this random column is still not being treated as numeric. See how it's kind of left justified? The numeric variables, like evil and like male, they're right justified. That's a sign to you that random is not numeric yet. Okay, we want it to be a numeric variable. If you want to check what is the type of a variable, you can use the command type of, just typing down here in the console. So the type of random is integer. An integer is what R is using to represent a factor here. We want it to be numeric. Alright, here is how we do it. We're going to go, this is going to be just a little bit strange appearing in the first instance, so dt random is going to be replaced with as numeric, and this is what we want, right? We want to create the variable in its numeric form, not in its factor form. And then we go as character dt random. The as numeric I think makes sense. The as character is not obvious. I won't go into the details of why you need to include that as well. Just trust me that if you have some numbers like this, which are being treated by R as being a factor, and you want to convert them into numbers that you can use in a regression, then it kind of requires these two steps. You first of all apply this as character command to the factor, and then you apply the as numeric to the characters. It returns to you a variable that you can use. So let's run that and look at our data set. And you can see that, they're in scientific notation, but you can see that these are now numbers, right? This is 1.348, and it's being treated as a number, recognised as a number by R. We could now do the regression, but I just want to show you one more thing before we do the regression, which is how we might restrict our data set just to get rid of these NAs in some different ways. This is often something that you will want to do. You won't want to retain the entire data frame that you've read in. You might want to get rid of either some of the observations with NAs or even all of the observations with NAs. So let's suppose we want to restrict our data frame, and by throwing away all of the observations where we don't have any observations on random. Okay, we're happy to keep those observations, those other ones with NAs, such as this mysterious evil guy here, where we have all of the numeric data, we just don't have a name. Okay, so we don't want to throw him away, but we do want to throw away some of these others that where we don't have the numeric data. So I'll show you that one first. So what we would do in that instance is to redefine our data frame, or we could set up a new data frame if you like. The data frame could be the data frame which contains, oops, that's the wrong kind of bracket, so I'll put in command and then tell you what's going on here. So we have dt random, and we'll need a comma there, won't we? So this is now redefining our data frame. So our original data frame, new data frame over here, okay? Now this part of the command is specifying which rows of the data frame that we want to retain, okay? So which which rows, okay? So the which rows we want to retain are those that satisfy this statement in here. Now, what's going on in this statement? First of all, the exclamation mark is our notation for not. So if you want to say not something, like not equals or not something else, exclamation mark. Is NA is a logical thing, and it will return a true whenever there is an NA in this variable, then it will return a false if there is not an NA. Okay, so is NA, before we deal with the not part, is NA is going to go for this variable false, because it's not missing, true, true, false, true, and so on. Then when we apply the exclamation mark to say not, it's going to flip that around, and it's going to say true for this one, because it's not missing. Okay, it'll say true, false, false, true, and so on. So the outcome of this command here is to pick out those observations which are not NAs. Okay, so which observations are not NAs in this particular variable. This comma here, and then nothing after the comma, is telling R to retain all of the columns in the data frame. If we only wanted specific columns from the data frame, we could list them after this comma here, but we're not going to do that. So just by comma and then bracket means retain all of the columns. Okay, so if we run that, far so good. If we check back out our data frame, you can see it's smaller now. What this has done is it's thrown away all of those observations where we don't have data on random. Okay, we have just the ones with the numeric values remaining. So that's one way if you want to restrict your data frame on the basis of having missing values removed for one particular variable. That's how you can do it. If you wanted to go even further and say, I don't want to retain any observations that have NAs in any of the variables, you could kind of go through and do this operation one variable at a time. Or alternatively, I'll just comment that out, alternatively what you could do is a much quicker command, which is this, na.omit dt. And that's a command which goes through row by row, and if any of the observations for any of the variables are an NA, then they're out. Okay, so if we run that and have a look what's left, we've now completely thrown away any individual who has an NA of any sort. Okay, so that's obviously excluding more observations, including just the observation for the individual who did not have a name, as well as the individual who did not have a gender and so on. Okay, so those are two different ways of removing observations from a data frame according to whether they are NA or not. Let's see if we can run this regression now. Let's just throw away all of those randoms which are missing and see how we go with our regression now. Oh, we have an error. The object is not a matrix. Oops, that was silly. So what I've done here, obviously, is put two squiggles in there. We need to have a plus, don't we? Let's try that. Okay, there we go. So that's given us a regression of the evil variable on the male dummy variable and log of random. So we fixed up that issue now. We can now take the log of it because it's numeric and we can include it in a regression. And this regression runs on 6 degrees of freedom, a total of 9 observations that are available for that regression. Okay, so what I want you to get from this little exercise is how you can handle just a couple of the different kinds of data that you can see coming your way in practice in some spreadsheets, dealing with variables that come in character form, variables that come in as NAs, and also variables that come in other forms of NAs that R doesn't recognise, and how you can recode those and deal with them in your data frame, and finally getting on to doing the analysis that you want to do. You will need to do a little bit of this in your tutorial exercise in week 4, just for example, and no doubt on other occasions besides.